Yes, student, in the previous video, we have observed that water sometimes can act as acid, but sometimes it can also act as base. That is, when HCl reacts with H2O, it forms Cl anion and H3O cation. So here the H2O act as an acid. And one more reaction we have checked, NH3 plus H2O. Here the H2O is donating its hydrogen cation to the NH3. That is, now here it acts as an acid. So if we find the self ionization of water, how can you write it? Suppose we are taking 2 mole molecules of water. Here one of the molecule act as acid and gives its H cation to the H2O. Thus the H2O converts into H3O cation, while the second one becomes what? OH anion. Isn't it? So here it acts as acid and here it acts as base, and in the reverse reaction H3O cation provides its H cation. Therefore now it becomes what? Conjugate acid, and being it is accepted, therefore it becomes what? Conjugate base. So we have checked in previous section. If we have to write the dissociation constant, that is what? K. So we can find its equilibrium constant, like it is product concentration H3O cation multiplied by another ion divided by the concentration of water. You can write here what? H2O, okay, twice. But H2O here used as solvent, okay, in pure state. So according to the law of equilibrium, the H2O from the denominator can be ignored. Thus it becomes K is equal to the product concentration of H3O cation multiplied by the product concentration of OH anion. Okay, here Kw is called what? Ionization constant of water, called ionization constant of water, okay, or also called ionic product of water, okay. Experimentally it is observed that H2O, that is, in H2O H concentration is only 1.0 into 10 to the power minus 7 m. Okay, we also know 1 mole, okay, of H2O produces equal moles of H cation and what? OH anion. Getting? Hence H cation is equal to OH anion. So 1.0 into 10 to the power minus 7 is equal to 1.0 into 10 to the power minus 7. Now place the value in equation 1. You can call it what? Equation 1. Kw is equal to H concentration multiplied by OH concentration, or it is equal to 1.0 into 10 to the power minus 7 multiplied by 1.0 into 10 to the power minus 7. So it is equal to 1.0 into 10 to the power minus 14 m square. This is the value of what? Kw. Getting? We also know in 1 molal H2O, its molality is 55.55 mole. That is in 1 molar, that is we can say in 1 liter. It is because what? 1 liter is equal to 1000 gram. So if we have to find number of mole, so number of mole is equal to 1000 divided by 18 is equal to what? 55.55. Okay. Student, on the basis of equation 1, we can show the nature of solution. Like first one, if H concentration, okay, is more than OH ion concentration, the solution will be what? Acidic in nature. If H concentration is lesser than OH concentration, the solution will be what? Basic in nature. And third one, what? If H concentration is equal to OH concentration, then the solution is considered as neutral solution. So here is the ionization constant and ionic product of water. Student, ionic product of water values which we have get, this value is at what? 298 Kelvin temperature. Okay, that is what? The ionic product of water is temperature dependent. If the temperature is increased, more and more amount of H2O can convert into hydrogen cation and OH anion. That is what? Its ionic product will increase.